Hello, everyone. I'm Artūras Šlajus. I'm CTO, Chief Technical Officer. You can see I'm a techie. I can't even put the words right. Unity 3D should be obviously in the top, like my... I'm a guy from the technical side of the games. And we have a game studio, and we make games for kids mostly. But what's interesting is we are a game studio, and we have one product that we've been developing for 2-3 years now. And we've grew from 5 people to 28 people. And we had some growing pains. And we've developed some ways to approach game programming. And I'm going to share that with you today. So, there's this problem. I have 30 minutes to explain something to you that melted my brain for 2 weeks when I encountered it the first time. It's going to be hard. And fun. But I guess I'm gonna kind of go through it, show you some ideas. They might not make a lot of sense to you at the moment. I'm not gonna explain them in depth. I don't have the time for that. If we have the extra time at the end of the talk, let's have a discussion. That is very welcome. But my goal here is to bring your curiosity forward, to make you curious about what the functional programming side of programming is. And a lot of people don't really know what functional programming is. When I talk to people, I say, hey, so do you know functional programming? And they're like, yeah, it's like programming with Pascal in school, right? It's like really old school. And, well, it is old school. It's been devised as an idea in the 60s or something. But it isn't obsolete. It's actually really useful right now, these days. So, yeah. Functional programming is something that you need to wrap your head around. And I ask you one thing, to not be immediately judgmental, because some of the ideas might seem a bit crazy at first. But just suppress your disbelief and enjoy the show. And my personal experience, how we as a company arrived in this kind of weird position where we do everything a bit differently from the rest of the companies in game development industry, is my personal experience. So, I've started programming in about year 2002. I was 14. And I took the normal standard route. I started learning PHP, and then I've started learning object-oriented programming and went into different programming languages. But most of them, well, all of them actually had the same paradigm of programming: imperative object-oriented programming. So, you have your objects, you have your classes, you have your variables that you can change, and then you have your methods and interfaces and whatever. And, you use that to build up your programs. And due to some circumstances, I've stumbled upon functional programming paradigm via a language called Scala, which has been rising in popularity. Even here in Vilnius, you have Wix, you have Adform, searching for Scala developers now. So I discovered that in 2012. And yeah, that was the moment when those 2 weeks where I was like, oh, what? what is happening? And at that moment, I wasn't working on games. I was working on, well, at that moment, I was working on games, but then I moved away from games into writing scalable software on clusters and really embraced the paradigm. But then I went back to games in about 2014, and I've noticed that some of the ideas, some of the things from the functional programming side make really a lot of sense when doing games. And we've been doing this kind of blend of imperative and functional programming from 2015, so 2-3 years now. And why is this? Why does this even matter? Everybody's making games. The games get shipped. They get released. Everybody's happy. What's the problem? Why do we have to bother? Well, the problem is games kind of are hard, and they often have problems. They are buggy. It's hard to write them. It's hard to maintain them. There's a lot of people involved in making them. So we really want, as developers, we want to write more correct, robust software that wouldn't have the really nice property of looking at the code you wrote a half a year ago and thinking, what I was doing here? We want to rely on the computer, on the compiler, to point out the errors that we make. Because we are stupid, like every human being is so stupid. They make so many illogical things, and computers are happy to do illogical things exactly as you specified them to do. But we want the correct behavior. We want no bugs. So helping computer to help us to say, hey, this thing you're doing, it doesn't make any sense, is very nice. Our company has this particular problem because we have the long update cycles. We're a mobile-based company. We do games for mobiles. We have about 60 games that are built from the same source code with different assets and different mechanics and different level packs. And just rebuilding the 60 games takes about 12 hours of pure computer running time. Publishing those games, sending them to the app stores, about an hour. And then there's the mobile users, the users that never update stuff. And now, you're from the point that you fixed something to the point that most of your users are actually having the version where the thing is fixed, it takes about a week for us. So we really, really don't want to make mistakes and then ship them. In web development, I've worked in web development, I've worked in backends. It's very nice there. You get an error, you go fix it, push it to production. 15 minutes later, you're sipping margaritas, everything's fine. Game development, not so much. Also, we have a medium-sized team. So, when you're working alone or with a buddy, that's fine. You know everything. That's cool. When you have a bigger team, lots of things start to happen at the same time. And you're not sure. Someone might change something, and things can break. You want to prevent that. So functional programming is often, by those who heard it, is often associated with scary words like monads and functors and applicatives and Clasley arrows. And those are very, very scary words. But mathematicians got to the ideas first, so they named all the things. Blame them. But really, in day-to-day game programming, it's mostly about being honest, about having honest functions. So what do I mean? take a look at these two functions, really simple functions. So one is parse integer. You give it a string and it gives you back an integer, right? But does it? What does happen if I give it, a string Johnny, right? What does it return? Does it return 0? Perhaps, but do you expect it to return 0? It probably throws an exception, but where does it state that? You don't know from the type what it's gonna do. And if you don't have the function source code, right, you don't know what it's gonna do. Well, you can read up documentation, but documentation expires and gets outdated. So this function kind of lies. Then find player in. You give it a pair of coordinates, and it's going to give you back a player. But what happens if the player isn't there? Well, you just return a null, obviously. But how do you know whether it is possible for this function to return a null? Or perhaps, if you don't find a player there, you will summon a new player there and will always return a player. You don't know that. So those functions are kind of like salesmen. They promise you things, but sometimes they don't deliver. Or this, right? We have something, let's say a player, and we say, yeah, I'm going to update your state. Here's your movement. Here's a flag whether you're animating. And there's, a string, what kind of animation you're playing. Does this make sense? Well, not really. If we're not animating, does it matter what kind of animation type we pass? What will happen? How does it make logical sense to say, I'm not animating, but I'm walking? Doesn't sound very logical to me. So why are you able to pass that? Are you sure that, somebody will not pass that and then have a hell of a fun time trying to figure out why this is happening? And does it make sense to have string as animation type? Can I pass every string? Can I pass Johnny as animation type? What about, dad or baby or cow? Probably we only have like 5 animations: walking, running, ducking, whatever. Why not encode that into type system so that compiler can say, by the way, Johnny is not really an animation, it's a guy. So please don't lie to me. We often see this in Unity 3D. You have some player, which is a mono behavior, but you can't create mono behaviors via constructors, but you need dependencies. So one solution is to use dependency injection framework. Another solution is to do this. You have a static method. You say, hey, here's everything you need to work. What's the problem with that? The problem is when you have a player reference, you never know whether it's been properly initialized or not. And you're going to call its methods, and you never know whether those methods will work or violently explode in your face. And while this isn't a problem when you're writing code, because you can catch those things in your test, it is often a problem when you're refactoring code. When a year has passed and some junior developer comes and rearranges some stuff, and now you're not sure, you cannot test all the cases. Testing games is hard, and now there's a case where, you get a player, but it's not initialized, and you ship the game with it, and you see, oh, well, now we have to fix this, and it's going to take a week for all the players to update. So a really easy way to mitigate that is just to have an inner class called init, which takes all the dependencies in a constructor. And instead of passing player, just pass player init. And when you have an instance of that, you are sure that it's been properly initialized. That if you're going to use it, it will work, and it will not explode. There are some things that we've learned is the norm, but are really terrible. So nulls. Nulls are lovely. Everybody loves null pointer exceptions, right? is the most fun thing in the world, except it's not. And as I mentioned, find player isn't an honest function. Sometimes it lies to you. Sometimes it says, I'm going to give you a player, but really it returns this weird thing which pretends to be a player, but when you actually try to do anything, it says, ha, I'm a null pointer. So we can express, we can write an honest function that expresses that, hey, sometimes when you find find a player here, I'm not going to have a player. And we can express that in a type system so that the compiler can tell us that, by the way, you've called this function, and sometimes it doesn't return a player, and you're not handling that. So please fix it. And this is done via an option type. You can Google it, just enter C# optional, and very easy. What this results in, we haven't seen a null pointer exception in our code in ages. Exceptions in general are also terrible. Exceptions are originally devised for exceptional things like, hey, I'm out of memory, or hey, something that you can't really recover that isn't a normal condition. And you shouldn't really use them for anything but that. Like, why does opening a file throw an exception? When you try to open a file, is it really that uncommon that the file cannot exist? Probably there's a better way to handle that. So parsing integers out of strings, it's its own case. C# has this method, try parseInt, and it's somewhat honest. It gives you a Boolean that says, hey, this succeeded or this failed, and it writes, if it succeeded, it writes the value into the parsed reference that you gave to it. But, C# standard library probably will not change. But if you write the code yourself, what guarantees that when I call this function, it will only write into past if the parsing succeeded? What if somebody changed the function that, if the parsing failed, parsed is set to 0? You then have a behavior that isn't really your intent, and that you have no way of knowing, but you have to look into this function source to know what it does. Again, an honest function just simply says, OK, give me a string, and I'm going to give you back a data structure called either. And it's going to either have a string explaining why the parsing failed, or the parsed integer. And now you have to handle both of those things, because otherwise you can't get a value out of that data structure. So the type system and the compiler forces you to think about problems there, whereas with exceptions, you have this problem. You call a method, it calls a method, it calls a method, and that method calls a method which throws an exception. Every time you call something, you have no idea whether that thing will eventually throw an exception or not. And it's a really hard way to code. There are some things from functional programming that are really useful in game development. So futures or tasks. If you've programmed in modern C#, not with Unity, you might heard about task. But the idea is that, so let's say you do a web request. You ask a server to give you some data back, a configuration file perhaps, and you can represent that as a value. You can say, here's a value that I'm going to have in the future. Here's a configuration file that will be there in the future. And then you can use that thing to say, oh, so when I'm going to have the file, I'm going to do this. Or when I'm going to have the file, I'm going to take a subsection of the configuration, and then I'm going to pass that object somewhere else. So we have this Tiny Lab Productions library, which is open source on GitHub. It's tailored to Unity 3D game development. We have a future implementation that doesn't have threading support. It's very lightweight. It's oriented towards Unity. Or you can use Task from C# standard library, which has support for threading, and it is a bit heavier because of that. Then there's reactive extensions, which are kind of link you for events. So you have a button, and when you click it, an event happens. You can represent that. You can think of that like an event stream. And if you have 5 buttons, right, you can think of that like 5 event streams. And then you can join them together with generic operation called join into one event stream and then pass that somewhere else. It's a way of thinking about events and events that happen over time as things. Things you can manipulate, things you can filter or map or flat map or join or split or zip or do anything that you can do with standard values. Again, we have an implementation in Tiny Lab Productions library. There's also a project called UniRX, created by these Japanese guys. It's a standalone project, more C#-ish from the naming perspective. Also has threading support, which we find isn't really that useful in Unity, and heavier. This isn't really that related that much to functional programming, but again, this is something that provides to the idea of validating things before shipping. So I don't know why Unity doesn't have this built in. Seriously, I don't. But how many times when you have serialized fields, how many times you said, okay, this thing I need, this is an enemy prefab, I need to instantiate it, but there's no way in Unity to say, this is needed, and if it's not set, when you're building stuff, please fail. So we have that. That is also very useful in preventing errors in build games. And what do you need for all this stuff? So it's very helpful for you if you want to do functional programming in Unity, with Unity. It's very helpful for you to use C# 6 or 7. And a lot of people don't realize you can do that with Unity. Unity's been stuck with an old compiler that's buggy for a very long time for no good reason, just because Unity. But you can actually, if you Google Unity C# 6 or 7, you can find this project. And we've been using it for like 1.5 years, 2 perhaps. What it does is it just goes into Unity internals and swaps out the compiler into the newer one. And no problems whatsoever. You can use all the new language features. A lot of people have heard and read on Unity forums like for each is bad. Do you know why for each is bad? Because Unity mono compiler that compiles your C# code is buggy. That's why is it bad. That is why it's bad. If you exchange it with a normal compiler, then it's fine. It makes development so much better. There's new language features, there's less bugs, everybody's happier. Works on desktop platforms, works on Android, iOS, probably doesn't work on consoles, so sorry if you're doing that. there's the library I mentioned. It's totally optional. I'm not pitching it. You can roll your own. If you want to do that, you can use other libraries. But we do have it. We put everything that we encounter and that we write out there to the open source community. It's production ready. We're using it for 2 years in our games. If you want, you can go there and read around and play around with it. And I can't recommend enough this book. It's an early access preview. It's all written. It's going to be released in July, but it's still technically a Manning early access preview book. But it explains all the ideas, so it caters to the object-oriented imperative programmers with experience. It explains to them why you should care about functional programming and how the ideas work to help you out, specifically in C#. So it's a book. I would say, if you do not know about functional programming, you're this guy with a hammer who's been hammering nails into the wall all his life. And one day you get this weird nail, which is, I don't know, it has some metal around it and it has a hole at the end, and you say, it's a kind of weird nail, but it works, and you smash it in. Can you realize what that nail was? It was a screw. And it's very hard to unscrew a screw when you hammered it in. If you disassembled Soviet furniture, you would know. It kind of a hole that you can't do anything with it. Kind of hacky. So yeah, if you have no idea that a screwdriver exists, well, then you hammer things in. So short summary. Please don't lie in your functions. Please make them as honest as possible. Applying the functional programming techniques and things allows you to consider which paradigm is better. Neither tool is the ultimate tool. It's very hard to, screw in nails as well with a screwdriver. But when you have both tools, you can choose the appropriate tool for the job. And overall, it makes the code easier to understand, more correct, and more robust to change. If you take just one thing from this talk, just stop using nulls, look up what option is, slap that into your project, and save a lot of time. Stop worrying about null pointer problems. And functional programming is really kind of a journey. You're gonna need. It's easier for people who don't know much, but for people who've spent 10 years like me doing stuff in a certain way, you kind of need to stop, take a step back, and take 2 steps forward in slightly different direction to allow yourself to become a better programmer. And that is it. Thank you. I still have 1 minute and 15 seconds of time.